Hello. Yes, today in this lecture, I am going to discuss about the one of the popular topic of networking is switching. What is switching? First of all, when there are too many devices, it is necessary to develop suitable mechanism for communication between any two devices. So, for direct communication between any two devices, one solution is to establish point-to-point communication between each pair of devices using mesh topology, because in mesh topology every device is connected to every other devices directly, and the bandwidth of the cable is shared between only two devices, and this type of topology is used for the situation when the privacy is major concern. But mesh topology is impractical for large number of devices. If number of devices are less, then mesh topology can be used. But when there are number of devices, so many devices, it is impractical, because the number of links increases exponentially. As we have seen in the topology video, in mesh topology, if there are n devices, then n into n minus 1 by 2 links are required for the connection, and n minus 1 input output ports are required for every device to connect to every other device directly. So this is not practical, this type of situation. A better alternative is to use switching techniques. This is the topic of today's lecture. The switching techniques leading to switched communication network. In the switched network methodology, the network consists of a set of interconnected nodes called switches, among which information is transmitted from source to destination via different routes, which is controlled by the switching mechanism. This is the basic model of switched network. The mechanism for moving data between different computers in the network and network segment is called switching. So switching is the mechanism for moving the data in the network and the network segments. The end systems of the computer network are connected to the switches. Here in this diagram, there are some yellow colored devices. These devices are switches which are used for the temporary connection, and the devices A, B, C, D alphabets, these are the end systems. So end systems of a computer network are connected to the switches, and the switches are connected to each other through communication links. All the network switches perform the following task. Whatever the switches are used in the network, they all perform the following task. First is receive data at their input port, determine where the data needs to go, move the data to the correct output port, and the last one is send the data out. Okay. Before going to the next topic, what is network switch? A network switch is a small hardware device that joins multiple computers together within one local area network. We can say that network switches operate at the layer 2 of the OSI model, that is data link layer. Network switches appears very similar to the network hubs but a switch generally contains more intelligence than a hub. Unlike hubs, network switches are capable of inspecting data packets as they are received, determining the source and destination device of each packet, and forwarding them appropriately. So by delivering messages only to the connected devices, a network switch conserves network bandwidth and offers generally better performance in comparison to the hub. Means switch is more intelligent than hub, we can say. Now the types of switching elements. There are three types of switches: telephone switches, datagram routers, and third one is ATM switches. These are three types of switching elements. Other switching element functions. There are some other functions also. First one is participate in routing algorithms. So routing decisions are made with the help of routing tables. And second is resolve contention for output trunks, in which link output should be given. It is also the function of switches. Scheduling. For this, schedule is prepared at which time, at which link the output is given. Third one is admission control. Which device will be allowed to give the permission to access the channel. These things we will discuss later. Here we are focusing on purely how the data will be moved in the network. And this is the taxonomy of switched network. Switched networks are classified into three categories: circuit switched networks, packet switched networks, and third one is message switched networks. And further, packet switched networks are further classified into two categories: datagram networks and the virtual circuit networks. We will see one by one these topics. So classification is packet versus circuit switches. In packet switch networks we use data packets, and data packets uses headers, and the circuit switched networks we use samples. They do not have headers. Connectionless versus connection oriented. Packet switch. In packet switching, all the data packets are independent. They follow different routes. They do not need to set up a path between sender and receiver. Dynamically they decide the route. But circuit switch networks are connection oriented. Before transferring the data, connection is set up, then data is transferred. After that, connection is disconnected. In connectionless services, means in packet switching, the data is known as datagrams. Now, circuit switched networks. A circuit switched network consists of a set of switches connected by physical links, in which each link is divided into n channels. Means every communication channel is divided into n channels using frequency division multiplexing or time division multiplexing. In frequency division multiplexing, whole bandwidth of the channel is divided into different sub channels, logically, not physically, and each device thinks that I am using separate line. In time division multiplexing, a time slot is allocated to each device, and in that slot only that device sends the data. A connection between two stations is a dedicated path made of one or more links. Each connection uses only one dedicated channel on each link. In the traditional telephone network, switching at the physical layer uses the circuit switching approach. So there are three steps in circuit switching networks. This is how this concept is used. It is shown in the diagram. Every link can be thought of n channels, and these are divided using frequency division multiplexing or time division multiplexing. It is shown these yellow devices are the switches, and these are the many devices. Three devices are using, and there is one channel, and every link will be divided into n channels using the multiplexing techniques. In circuit switching, what is a circuit switch? A switch that can handle n calls has n logical inputs and n logical outputs, and the value of n can be up to 2 lakhs. In practice, input trunks are multiplexed. Multiplexed trunks carry frames, set of samples. What is the goal? Extract samples from frame, and depending on the position in frame, switch to output. For this, demultiplexing switches multiplexing are used. Example of a circuit switched network. Let us consider a circuit switched network to connect 8 telephones in a small area, and the communication is through 4 kHz voice channels. We assume that each link uses frequency division multiplexing to connect a maximum of 2 voice channels. So the bandwidth of each link is then 8 kHz. In the next slide, there is a diagram figure that shows the situation. There are different telephones 1, 2, 3, 4, 5, 6, 7, 8, and how these telephones are connected using circuit switched networks. It is shown. The figure shows the situation. Telephone 1 is connected to the telephone 7. Yes, this telephone 1 is connected to the telephone 7. Telephone 2 is connected to the 5. 2 is connected to the 5. Okay. And 3 to 8 and 4 to 6. Of course, this situation may change when new connections are made. The switch controls the connection. In this diagram, switch controls the connection. If new request is made, connection can be disconnected, and that resource can be allocated to the another connection. But in circuit switching, if a connection is established, the data will be transferred, and after that connection is disconnected. Throughout that duration, that resource is reserved for for the communication of those two devices. This is the delay diagram of in a circuit switched network. There are two devices which wish to communicate, A and B, and there are two switches between them. So there are 3-step process is used in the circuit switched network. First, time is increasing downwards. There is the connection request by A. This connection request, when reaches through these links to the B sends back to the confirmation message to the A. The duration which is used for this is used for the connection request. Total delay. So this is the connection request, and after that connection is established, data is transferred. So this data transfer is shown in the slope line. Why it is not a straight line? Because the time at which the data is transferred will be initiated for the transmission. It will not be reached at the destination at the same time. It will take some time, some delay. So that is why it is shown in the form of slope. And any one party among A and B, if any party wishes for the disconnection, the request is made and all the resources are released. See, the total delay will be connection time, the data transmission time, and the disconnection time. It is shown in this figure. Okay. So now packet switch network. Packet switch networks are also called datagram networks. Datagram networks. Why it is called datagram? Datagrams are the independent data packets. In data communication, we need to send messages from one end system to another. If the message is going to pass through a packet switch network, it needs to be divided into packets of the fixed or variable size. So when the data is divided into several packets, these packets, size of these packets can be fixed or variable size. It depends on the situation. The size of the packet is determined by the network and the governing protocol. What are the rules is being used? In a packet switch network, there is no resource reservation, but in switch network, there is resource reservation. In packet switch network, the resources are allocated on demand. So, which switching technique is used in the internet? Answer is datagram approach. The packet switching at the network layer is used. A datagram network with 4 switches is shown in this figure. There are 4 devices, 4 end systems, and these are connected with the help of switches. This is known as datagram network. The data which is want to communicate, device A wants to send some data. So first that data is divided into some packets. Here it is shown in the 4 packets. First packet, second packet, third packet, and fourth. In this order it is sent to the network in the subnet. When first it reaches to the first switch, based on the current traffic and delay, there are so many factors. The route switch decides that which packet has to send in which direction. So packet 1 and 3 is sent to the another switch, packet 4 is transferred to the second switch, and packet 2 is transferred to the third switch, and they follow different path due to some congestion or any another issue. It is shown that at the receiver end, that is X, those packets are received in the different order. They are not received in the order as they are sent. So some reassembly is required at the receiver end so that actual data can be retrieved. So this is the functioning of the packet switched network. This is the routing table in a datagram network. A switch in a datagram network uses a routing table that is based on the destination address. The destination address in the header of a packet in a datagram network remains the same during the entire journey of the packet. So packet follows different route, but the destination address will be same throughout the journey of that packet. Port numbers will be different, routes will be different, but the destination address will be same. This is the delay diagram in the datagram network, that is in packet switch network. There are two devices A and B, both want to communicate. A is sending data, so some transmission time will be required. After that, that data is received at the switch 1, we can say router, and after that, after some time, it sends the data to the another intermediate node. There is some waiting times are also used. So if when we calculate the total delay, these times will also be considered, and as soon as we are going forward downwards, the time is increasing, and this is the delay in the datagram network. Next is virtual circuit networks. A virtual circuit networks is a cross between a circuit switch network and a datagram networks. It has some characteristics of both. So virtual circuit networks has both the characteristics of the circuit switching and the datagram networks. The switching at the data link layer in a switched wide area network is normally implemented by using virtual circuit techniques. And how it works, how it is connected, it is shown in the diagram. There are 4 end systems and there are 6 switches are used in this virtual circuit networks. These are the virtual circuit identifiers in the virtual circuit networks. Data and the virtual circuit identifier 14 is used, and after passing this switch, data is same and the virtual circuit identifier is changed. Switches and tables in a virtual circuit network. In this, there are data packets, and there are different virtual circuit identifiers in different data packets. Incoming and outgoing ports are used. So these all data are prepared, maintained in a table, and that table is used for the finding the routing decisions. Source to destination data transfer in a virtual circuit network. In a virtual circuit switching, all packets belonging to the same source and destination travel the same path, but the packets may arrive at the destination with different delays if the resource allocation is on demand. Okay, so every switch maintain its table in which there are incoming and outgoing fields. For incoming, there is some port and virtual circuit identifier, and for outgoing, there is also some port and virtual circuit identifier. It is shown in the diagram. This is the delay in the virtual circuit network. Some connection setup, and after connection setup, data is transmitted. So some transmission time will be required from one node to another node, data transmission, and after that connection disconnection request, that is tear down, is shown here. So all these delays are summed and the total delay can be calculated in this way. These are the repeaters, bridges, routers and gateways. Where we use repeaters? At physical level, and bridges at the data link layer. And at the data link layer we use physical addresses, that is also known as MAC address. And what is the use of bridges? Discover attached stations by listening techniques. We will see listening techniques in the next videos. Router at the network level, layer 3, and routers are used in routing protocols. Application level gateways at application level, and these gateways treat entire network as a single hop. For example, mail gateways and transcoders. In this way, gain functionality at the expense of forwarding speed. For the best performance, push functionality as low as possible. Structure of a switch. We use switches in a circuit switched and packet switched networks. In this section, we will discuss the structures of the switches used in each type of networks. Crossbar switches. Crossbar switches with 3 inputs and 4 outputs is shown in the figure. A crossbar switch is a basic building block of a switch, is a metallic cross point or a semiconductor gate that can be enabled or disabled by a control unit or a control station. It is shown in the figure. Crossbar switches, simplest possible space division switch. Cross points can be turned on or off. For multiplexed inputs, need a switching schedule. Internally non-blocking techniques can be used for the crossbar. In this diagram, it is shown in the multi-stage switches. In a 3-stage switch, the total number of cross points is 2kn plus kn divided by small n square, which is much smaller than the number of cross points in a single stage switch. So there are different stages, and in multi-stage switches, the number of switches required is comparatively much less than the single stage switch. Multi-stage crossbar. In a crossbar, during each switching time, only one cross point per row or column is active. In multi-stage crossbar can save cross points if a cross point can attach to more than one input line. This is done in a multi-stage crossbar, and it needs to rearrange connections every switching time. Multi-stage crossbar can suffer internal blocking. Number of cross points can be less than n square. It finding a path from input to output requires a depth first search technique. This scales better than crossbar, but is still not too well. This is the time space time switch. In this, flip samples are allowed for input and output run. It gives more flexibility for the lower call blocking probability. Thanks. So in the brief, I am going to tell you about the difference between circuit switching, packet switching and message switching. First of all, I am going to compare circuit switch, packet switch and message switch. If we talk about the routing, in message switching routing is manual. In circuit switching, selected during call establishment. But in packet switching, each packet routed independently. Means there is dynamic routing technique is used. But in circuit switching, before transmission of the data, a circuit is established. In circuit switching, dedicated physical path is required. In packet switching, dedicated physical path is not required. In circuit switching, each packet follows the same route, but it is not possible in the case of packet switch network. In circuit switching, every packet arrives in the order, but in packet switching, this may not happen. It depends on the situation. In circuit switching, if any switch crashes, this is the very fatal situation. But in packet switching, if any switch crashes, alternate switch can be used. Alternate path can be used for the data transmission. Whatever the bandwidth available for the circuit switching is fixed, but in packet switching, bandwidth availability is based on the dynamic situation. There is no possibility of congestion during the data transmission in the circuit switching. Congestion can occur only at the time of connection setup time, but in packet switching, on the transmission of every packet, there is possibility of congestion. So there is no wastage of bandwidth in the circuit switching, but in packet switching, bandwidth can be wasted. A store and forward mechanism is required in packet switching, but in circuit switching, there is no store and forward mechanism is required. So this is the end of this lecture. Thank you.